Good morning, everybody. I'm Jonathan Pokorny from SWARCO. I'm delighted to be joined by Gary Lin from Monotch. We're going to be talking to you about a case study from Talking Traffic in Helmand, Talking Traffic. You've heard about Helmand yesterday and the amazing things about Talking Traffic. So we'll start off with a recap of Talking Traffic and a sort of deeper dive from yesterday on the dashboard, and then we'll look at the use case, and then we'll have a quick talk about what's going on in Finland and also in the UK. So without any more time from me, I'll hand over to Gary Lin.
Well, thank you, Jonathan, and the SWARCO UK team for inviting Monotch to speak here today as an innovation partner. I'd like to quickly do a quick recap on the Talking Traffic ecosystem. It's a program that really kicked off Monotch's collaboration with SWARCO years ago before our recent announcement of a partnership. So the Talking Traffic program, which was originated by the Dutch Ministry of Infrastructure and Water Management. It was a 4-year program that ran between 2016 and 2020. And it was participated by more than 60 local and regional road authorities, as well as industry partners. The original idea was to facilitate the real-time data exchange across a public and private data chain in order to, between roadside infrastructure and road users, to facilitate safer and more sustainable and more efficient road travel. Well, now in 2024, the Talking Traffic program has left a legacy of a growing ecosystem with defined roles for both the road authorities and the industry partners, which serves as a structure for the ongoing services that are still active in the Netherlands. On the domain of the road authorities, they are responsible for the connection of the roadside equipments and the public fleets onto the public CITS data hub. The public CITS data hub is in charge of a few functionalities, including the data exchange and aggregation, data quality monitoring, and the governance management. And the Dutch government has decided to procure the service from Monotch to run this public CITS, to supply this public CITS data hub to them. Once the data has been connected to the public CITS data hub, information such as traffic information and other types of warning messages are made free of charge to private service providers with their services serving road users. So these are applications such as onboard units and navigation apps, which utilize these public information to display it to their road user-facing user interfaces. So a few of the key principles of Talking Traffic are openness and interoperability. To ensure the interoperability is maintained throughout the entire ecosystem, the Dutch government made it obligatory for all the signal provider to connect the traffic light controllers to the public CITS hub and utilizing open and international standards. So we have standards for the connection to roadside equipment, which was developed with the industry, called the CITS subject interface. And towards road users, we utilize the C-Roads basic interface to communicate data to private services. On top of that, we also utilize standardized message formats. Here we have what we call the CITS Dutch profiles, which was which is based on European ETSI standards. And on top of that, last but not least, the authorities have also access through the public CITS hub of management consoles that which they have control over data sharing rights and also organizational access towards the platform. The setup has been also copied in Belgium in the mobility data program, and across the two deployments, we've connected to more than 1,500 intersection and traffic light controllers from SWARCO, but also other signals provided are active in the Dutch and Belgian market, such as Unex, Vialis, and other local suppliers as well. So today I'd like to deep dive on one of the use cases that we've rolled out nationally in the Netherlands, which is the traffic signal priority use case, which I don't think is a stranger to most of you in this room. Historically, this use case has been more catered to emergency services or buses, but with the nature of the talking traffic and its connected vehicle aspects, we have reframed this use case as a means to help local authorities empower them in local mobility policy implementation. What I mean with that is that we've seen local authorities utilize this connected vehicle setup to assign policies in the form of priority to specific vehicle groups based on the local mobility challenges or policies. So this includes, for example, towards logistical vehicles near logistical hubs, or to platoons of bicycles at busy intersection near schools. So it's a much more dynamic system that incorporates more road user groups and being able to directly apply policy towards them. And this has been done in an explicit way and an inexplicit way. In the explicit method is that through these connected vehicles, they share priority requests, which is passed through Monotch's platform to the different signals provider and their algorithms to make the ultimate decision of changing the lights. Or we also utilize vehicle data that are collected through different mobile applications or AI cameras that detects different road users, such as bikes or pedestrians, and feed it as an input for the controllers to make their decisions. But bringing back to the point of using the traffic signal priority use case to empower local mobility policy implementation, one of the challenges was to achieve consensus of what are the priority rules with all the different road user groups. So Monotch, we have created an application that is offered as part of the public CITS hub called the Priority Broker Configurator. This is an application where local authorities can translate their policies into priority rules per intersection to centrally create it, store it, and share it with other stakeholders in the ecosystem. So both to the signals providers, but also the private services that are connected. So there's consensus with all of them of which type of vehicle, under what conditions, and what time of the day they can get priority and intersections. And it is also it's used in the validation chain to ensure that the requests are actually granted in intersections that are applicable. And behind the scenes of this use case, the public CITS hub supplied by Monotch also has continuous quality management over this use case. So we have dashboards and reports available for all the different stakeholders, where we monitor the connection to the different systems, whether it's traffic light controllers or other detector systems, over their connection quality, but also monitor on the data quality in terms of the conformity of the messages that we receive from them. And on top of that, we also monitor the use case quality. So as an example, one of the use case KPIs that we monitor is whether emergency services actually get priority at the intersection. What we do is we compare the priority requests that we receive and the actual signal changes that we receive from the controllers. And we see the percentage of when, whether they're granted or not. And on top of that, there are additional governance options for authorities in terms of being able to configure their data quality policies, so being able to configure what kind of KPIs they want for each one of the connection, message quality, and use case quality statistics, and also being able to centrally manage the administration of this data ecosystem. So by assigning role-based access to the dashboards and other connected modules, so having control over which supplier or which stakeholder within your organization gets to see and control what. And last but not least, the insights that we have generated by monitoring all these feeds, they are also actionable insights. So we have automated features that we can alert the relevant stakeholders when there are anomalies or report them. But also we can automatically drop or ban connections when we see that there is a faulty connection that's sending unstable data. And I'll pass the floor back to Jonathan, which will deep dive into one of our customer cases for freight priority. Thank you.
Thanks, Gary. The case I'm going to talk about particularly is a road called the M470. You heard about Helmand yesterday. Apologies, Luke, this is not Helmand. This is Delft. The M470 is a provincial road. It connects two very major highways, quite a lot of signalised junctions along it, and it gets a lot of truck traffic, a lot of HGV traffic because of its location. And that was causing a lot of problems, a lot of congestion. Pollution was the big problem they were worried about because of all the stop-starting of the HGVs at the signals. So what we did, as you've seen already from the talks from yesterday and from Gary today, there are these multiple layers of priorities that can be granted within the talking traffic ecosystem, and using our inflow traffic adapter, that also is a priority-based system. The particular case, obviously, in this one, when it moves forwards, is trucks. And the way this worked was that within the trucks there was an app that was constantly giving out CAN messages and data to the system, to the network, every 10 seconds or so. So you heard yesterday about the billions of messages every day. That's why you're getting billions of messages every day within talking traffic. And every 10 seconds a message is given out, and as the truck approaches a signal, it sends a message which effectively is a priority request. That goes into the SWARCO cloud, then down to the Monotch layer. Monotch does its thing with data quality and validation and passes it on to the inflow adapter at the roadside. The adapter asks the question, is this truck entitled to priority, yes or no? And if it is, it then includes that into its calculation of timings of the signals and whether priority can be granted. It takes in the normal things like traffic flow that you'd all be used to from loops and so on, but it also lays on your policies of priorities and other things and CAM data as well. And if it can give the truck a green light, it sends a message back through the route I've just described back into the cab as a speed advisory. So the driver will be told, drive at this speed, and you'll get to the signals on green. That isn't a one-off calculation. That carries on, and as the truck gets close to the lights, the frequency increases up to once a second. So that calculation is continually being refreshed and the speed adjusted accordingly. But at some point, it's locked in, it's granted, the truck gets priority. And what did they find on the M470? They were able to give priority in 80% of cases, and the impact of that was they reduced the number of HGV stops by 60%, which is dramatic because what they were trying to do was reduce emissions, and they got a 5% reduction in emissions. But it wasn't trucks getting priority at the expense of other road users, because what they found was without trucks stopping and starting all the time, the cars flowed more freely, and so all stops reduced by 80%, and the overall journey time on that road fell by between 5 and 10%. There were lots of things we could have talked about when Darren asked to talk about an innovation project. I felt we should do one that's real and proven and not a pilot or a test bed. This is real, it's live, it's still working. I've said that priority can be used to implement policies. What do I mean by that? Well, elsewhere in the Netherlands, they've used similar systems, and they've said to the truck companies and to the drivers, if you use this system and drive on these roads, you will get priority at the lights. If you try and use the minor roads or other routes through our urban area, you won't get priority. The truck companies like it because it makes their journeys predictable and it reduces their fuel consumption. And the drivers love it because it makes their job easier. Stopping and starting all the time in an HGV is much harder than driving at a constant speed. And so by giving priority to trucks and giving them routes to follow, you can actually implement local authority policy, regional policies through technology. And that's doing it through the carrot approach rather than the stick approach of banning them or fining them or something else. Briefly touch on CITS in Finland in case you were at Intertraffic last week. We've seen the news groups. So after Netherlands, after Belgium, we've just announced with Monotch a joint collaboration to roll out the infrastructure and capabilities to provide similar functionality, similar performance into Finland. And I want to stress very, very clearly that Monotch and SWARCO are separate independent companies and that these are open platforms. So as within Talking Traffic in the Netherlands, as with the Belgium system, our competitors are selling equipment and their systems in there as well. This is an open ecosystem because quite clearly, if we're going to have connected vehicles in the future and CITS environment, it can't be proprietary, it can't be closed. It has to be all the suppliers able to use the system, everyone can provide into that system so that I can drive from Plymouth to Newcastle and not have black spots where I'm going through a system where the supplier isn't part of the network. Everyone can play in that open. We believe that's the way forward for the connected future that we all want. Mentioned briefly CITS in UK. I've touched on inflow earlier on. You know, traffic control is changing and we've had systems around for many, many years now. I'm sure that everyone in this room knows more about them than I do. But we're now moving into policy-based adaptive and then we'll be moving into cooperative systems and connected vehicles. Inflow is a policy-based system. I'll explain about how that works in a moment. But it's at its core, it's also CITS enabled, it's cyber secure, it's GDPR compliant, and it's designed for the cooperative futures that we're all planning for. What Inflow will do, it will optimize an individual junction, so akin to Mover. It will also optimize corridors and groups of junctions, so akin to Scoot. So it's a single solution for both. It's policy-based, so you have a graphic equalizer type approach to different categories of user, different scenarios such as preferring journey time or preferring environment, what have you, move those sliders around. I have to say, I think most people in this room know what a graphic equalizer was, but we were on a webinar recently and a young graduate put their hand up and said, what's a graphic equalizer? But I certainly can remember them. But what it does, it takes those various weightings, it adds it to the normal traffic data you'd get from loops and other detectors. It adds in data from CCAM and connected vehicles, and it develops a short-term model, runs various scenarios, and does the signal timing accordingly. So, yes, it gives you optimization, but it also gives you prioritization, and it gives you information. So it provides information back to the driver, back to the vehicle, time to green, or whatever you happen to want. We've got thousands of inflows deployed in the Netherlands, in many other countries as well. We've had a bit of time to get it ready for the UK market, but we've got our first deployment now up in Crewe in Cheshire East, much too soon, and I realise this is totally non-scientific, but the data is being collected and we will be presenting comparisons with for later in the year at various industry events. But the first deployment seemed positive. More deployments, more junctions are going in at Cheshire East over the next coming weeks and months. So that was really a very quick run through of what we can provide. Coming all the way from the Netherlands to talk to us. That's it. Thank you very much.